Hello everyone, my name is Priyanka and I welcome you all to my session. Let's read our question. It says that derive the expression for the heat produced due to a current I flowing for a time interval T through a resistor R having a potential difference V applied across its end. With which name is the relation known? And then we have a small numerical, that is how much heat will an instrument of 12 watt produce in 1 minute if it is connected to a battery of 12 volt. So consider a resistor of resistance R. So we have a resistor of resistance R. Let the current flowing through the resistor be I and the potential difference applied across it be V. In time t, let Q be the amount of charge flowing through that conductor. So work done in that moving charge is given by V is equal to W is equal to V into Q. So that's the first relationship. According to definition of electric current, Q is equal to I into T. So we can name it as equation 2. Putting the value of 2 in equation 1, we can say that W is equal to V I T. As the work done is dissipated as heat, therefore heat produced is given by work done, which is equal to V I T. According to Ohm's law, we are knowing that V is equal to Ri. Therefore, putting the value of V in the above equation, we can say that the heat dissipated in time t across the conductor is equal to I square RT. So, this is known as the Joule's law of heating. So, it is called Joule's law of heating. Now, in the numerical, it is told to us that the power is 12 watt. The voltage applied is 12 volt and time is 1 minute, which we can take it as 60 seconds. So the total heat dissipated is given by VIT. However, V into I is equal to power, so we can tell that H is equal to P into T. So power is 12 and time is 60. Therefore, the total heat is 720 joule. So that's the solution for the problem. Have a great day. Bye-bye.